This video has been put together to help you with your 4Parle test on triangles. Your test will have 3 questions. You will have a maximum of 30 minutes to complete the paper. There are no calculators allowed. And you must remember that the written communication and full workings are essential. So make sure you think exactly about the language you're using, the arguments you are presenting mathematically, and make sure your work is set out clearly so it can be assessed properly. This test is graded and the results will appear on Pronote. So the things you need to remember for the assessment are the angles in any triangle add up to 180 degrees. Now remember, you use a notation such as this, where if you have a given triangle, the 3 corners are added up to 180. So say you were given one of the angles. Let's say that in this example here, let's say that angle M is 85 degrees and L is 35 degrees, and we want to find angle K. So the first line you would write is this one here. K plus L plus M equals 180. Then you would put in the numbers and letters from the actual question. So we've got K is the thing we're trying to find, plus L, which is 35, plus M, which is 85, and that equals 180. So K can be found by doing 180, subtract 85, and also subtract 35. 85 and 35 together will make 120, so K would be 60 degrees. So angle K here equals 60 degrees. If you asked a question to find a missing angle on a triangle, these are the steps you would need to write down, even if it's embedded inside another question. Facts you will need to know, or might be useful, will be the isosceles triangle. The isosceles triangle has, if you consider a base side, the bottom 2 angles will be identical, and the 2 sides there will also be identical. Also, a fact worth knowing or remembering is that an equilateral triangle, all the angles are 60 degrees, all the sides are the same length. Other things that might be useful. Angles are opposed by the vertex. So angles, opposite angles, basically when 2 lines cross, the opposite angles here will be equal. So these 2 marked in blue will be equal, and if I mark in red, these 2 angles here, also mark in black, these 2 angles here will also be equal to each other. So opposite angles are equal. We have a thing called complementary angles. These are angles that add up to 90 degrees. So if we have a right angle and it's split into 2 angles here, these 2 added together will make up the 90. Another way of looking at this is, say we had a situation like this and I gave you this one as an angle of 50 degrees, and I ask you to find angle BAD, then you would need to state that complementary angles add up to 90, right angle is 90, and then you could do something like CAB plus DAB equals 90 degrees, and then it builds up in the same way as we had for the triangle problem. So CAB is 50 degrees plus DAB equals 90. DAB is equal to 90 minus 50, which equals 40 degrees. You should also be aware that additional angles, as they're called, or angles on a straight line, are adding up to 180 degrees. So here we have 2 angles together on a straight line. If this angle here was 80, this angle here would be 100. And again, the steps, you'd follow a similar pattern to this by stating that DEF plus GFE equals 180, fill in the missing angles, and then work out the missing angle that you're looking for. Other things that may come into play, and these could be embedded within a shape as well as within a problem using parallel lines. We have corresponding angles. So we have 2 parallel lines here, this angle here and this angle here. This one corresponds with that one, and they are the same size. You can see they kind of look the same, but because these 2 lines are parallel, they most definitely are identical. One way of spotting them is to look for a F shape. I draw a little F shape on here. It's upside down, but the angles inside the F are the ones that are highlighted in pink, and those angles will be identical. We also have the alternate internal angles. Again, this is involved with parallel lines, and it can appear within shapes as well as within parallel lines. And what we have here is we have these two angles here, so this green one and this green one here, they alternate. These two angles are the same. The thing to look for on this one is to look for a Z shape. If you see the Z shape like that, the angle inside the Z, or the angles rather inside the Z, will be equal. Okay, other things. Now looking at equal triangles, that's the main focus of the assessment. Two triangles are said to be equal if all three angles are the same and all three sides are the same. So if two triangles share three angles and three sides the same, they are equal. In English, we also use the word congruent. To prove equality of triangles, you need to prove one of the three rules, one of the three cases. So the first one is side, side, side. That is, if the three sides match on the two triangles, then the two triangles are equal. Here we can see that AC is the same length as GE, AB is the same length as FE, and BC is the same as FG. Three sides the same on both triangles, so both triangles are said to be equal. Remember, you must put the written sentence. You can't just shorten it to SSS. You have to put, to actually state that the three sides are equal to each other, therefore three sides the same length, therefore the triangles are equal. The second case would be side angle side. Again, you need to put the full sentence. And here we have two triangles where the angle and its two sides are the same on both triangles. So we have an angle of 30 degrees. The two sides of this angle here are 7 and 5, and here they are also 7 and 5. So two angles have the same measure, and the two sides either side of that angle are also identical. The third case is angle side angle. And if we look here, we have a side and its two angles are the same. Here we have a 6 centimeter and a 6 centimeter. We have a 40 degree and a 50 on one side and a 40 and a 50 on the other one. So these are equal, these will become equal triangles. Again, you must put the full sentence. If two triangles have a side of the same length between two angles of the same measure, then they are equal. A statement of like that with the actual statements to say AB equals LK and so on will be enough to prove that the triangles are equal.